And welcome to week 1 of CS195 web development. Today's lesson is the web and HTML. What we're going to go over today is understanding how web pages are sent across the internet. What is the process when you click to get a web page before it ends up on your browser? Then with that, we'll understand what protocols in HTML have to do with this process. Our objective is to understand how websites are stored and then transmitted to your browser. Because as we're going to build this, we're going to build our own web pages, so you need to understand how this works. At the end of this, you'll be able to explain and describe how a web page gets displayed in the browser when you type in a URL. So that's our success criteria. You'll be able to understand and explain what happens when you go to a URL and then all of a sudden the web page shows up on your screen. So, how do you get a web page? Big things we're going to go over is, most of us know what the internet is, but what happens when you request a page? What is this thing called DNS? Because when you actually type in google.com, the internet doesn't look for google.com, it looks for something else, an IP address. And then what are these protocols I'm talking about? HTML, HTTP, what do they have to do with getting that web page to you? And finally, what is the browser's role in all of this? So with this, we're going to add a couple of videos, and then we'll summarize up.
I'm Jasmine Lawrence, and I'm a program manager on the Xbox One engineering team. One of our biggest features is called Xbox Live. It's an online service that connects gamers from all around the world, and we rely on the internet to make that happen. This is no easy task, and there are a lot of things happening behind the scenes. The internet is totally changing how people interact and connect. But how does it work? How do the computers all across the world actually communicate with each other? Let's look at web browsing. First, you open a web browser. It's the app you use to access the web pages. Next, you type in the web address, or URL, which stands for Uniform Resource Locator, of the website you want to visit, like tumblr.com.
Hi, I'm David Karp, the founder of Tumblr, and we're here today to talk about how those web browsers we use every day actually work. So you've probably wondered what actually happens when you type an address into your web browser and then hit enter. And it really is about as crazy as you can imagine. So in that moment, your computer starts talking to another computer called a server that's usually thousands of miles away. And in milliseconds, your computer asks that server for a website, and that server starts to talk back to your computer in a language called HTTP.
I'm going to pause here because we're not going to go over and we're not going to watch the DNS part of this. But what really happens in between this moment, and it's important you understand how this works because it'll be on the test, is your computer, you type in the address, it goes out. It doesn't reach the server yet. It has to go out and say, hey, tumblr.com, what's its IP address? That's the domain name system, right? DNS. So at that point, it goes out, asks for what Tumblr, google.com is, gets its IP address. It's normally a 12-digit number, 172.15.67.34, something like that. And then this is what happens. Once you get that IP address, it can navigate the internet with that IP address to this server, which is just a computer, a really big computer that has the files on it. This concept, this web server, is important to understand that they have these located all over the place. In fact, just some in Umatilla, as there'll be a couple of factories over there. So they're just rooms full of computers that look pretty much like this, just walls and walls of this. And now he's going to go over the actual protocol that's used, but you need to understand that really this computer is going to go out and say, okay, what's Google's, Tumblr's IP address? It'll get it back, and then it'll go and start the request for the web page.
And HTTP stands for Hypertext Transfer Protocol. And you can kind of think of it as the language that one computer uses to ask another computer for a document. And it's actually really pretty straightforward. If you were to intercept the conversation between your computer and a web server on the internet, it's mainly made up of something called GET request.
So you can kind of see this information back here, but this text is what he's saying it sends. It says, hey, here's all this information. I want to get your web page. And then you're going to see what it sends back.
Requests. And those are really very simply the word get and then the name of the document that you're requesting. So if you're trying to log into Tumblr and load our login page, all you're doing is sending a GET request to Tumblr's server that says get/login. And that tells Tumblr server that you want all of the HTML code for the Tumblr login page. So HTML stands for Hypertext Markup Language. And you can think of that as the language that you use to tell a web browser how to make a page look. So if you think about something like Wikipedia, which is really just a big, simple document, and HTML is the language that you use to make that title big and bold, to make the font the right font, to link certain text to certain other pages, to make some text bold, to make some text italic, to put an image in the middle of the page, to align the image to the right.
And this right here is what we're going to learn in this class. How do we use these tags to make this web page? At the end of this lesson, I'll kind of show you that really you are just sending a bunch of this across the internet when you create a page, when you have a web server, when you look for a web server. It's nothing but this. So we'll take an example of that in a little bit.
To align the image to the left.
The text of a web page is included directly in the HTML, but other parts, images or videos, are separate files with their own URLs that need to be requested. The browser sends separate HTTP requests for each of these and displays them as they arrive. If a web page has a lot of different images, each of them causes a separate HTTP request, and the page loads slower. Now, sometimes when you browse the web, you're not just requesting pages with GET requests. Sometimes you send information, like when you fill out a form or type a search query. Your browser sends this information in plain text to the web server using an HTTP POST request.
So let's say you log into Tumblr. Well, the first thing you do is you make a POST request. That is a post to Tumblr's login page that has some data attached to it. It has your email address. It has your password. That goes to Tumblr's server. Tumblr server figures out that, okay, you're David. It sends a web page back to your browser that says, success, logged in as David. But along with that web page, it also attaches a little bit of invisible cookie data that your browser sees and knows to save. And that's really important because it's really the only way that a website can remember who you are. And all that cookie data really is an ID card for Tumblr. It's a number that identifies you as David. And your web browser holds on to that number. And then the next time you refresh Tumblr, the next time you go to tumblr.com, your web browser knows to automatically attach that ID number with the request that it sends over to Tumblr server. So now Tumblr server sees the request coming from your browser, sees the ID number, and knows, okay, this is a request from David.
Now, the internet is completely open. All of its connections are shared, and information is in plain text. This makes it possible for hackers to snoop on any personal information that you send over the internet. But safe websites prevent this by asking your web browser to communicate on a secure channel using something called Secure Sockets Layer and its successor, Transport Layer Security. You can think of SSL and TLS as a layer of security wrapped around your communications to protect them from snooping or tampering. SSL and TLS are active when you see the little lock that appears in your browser address bar next to the HTTPS. The HTTPS protocols ensure that your HTTP requests are secure and protected. When a website asks your browser to engage in a secure connection, it first provides a digital certificate, which is like an official ID card, proving that it's the website it claims to be. Digital certificates are published by certificate authorities, which are trusted entities that verify the identities of websites and issue certificates for them, just like a government can issue IDs or passports. Now, if a website tries to start a secure connection without a properly issued digital certificate, your browser will warn you. That's the big...
Let's be honest though, most of you will just go ahead and click on that anyway, so that's a good reason why you don't go ahead and click on that. Alright, that's pretty much the end of this video. This was a huge, broad overview of the internet. and how it works. And we're not going into, there are other classes that go more into how the internet works and routers and stuff like that. But the key is that whole, you click on a link, you type in a URL, you have to get the IP address, which uses DNS, the domain name server service, and then you can actually go and say, hey, web server, give me the web page, and it just sends you a file. It is just a file that it sends you. We got 2 more videos that are going to kind of go a little bit more in detail on this, and then kind of how your web page does this. So this one right now is rendering the page. You just got the web file. Now what happens?
Hi, in this video we'll be talking about browsers. So what is a browser? Well, introducing browsers. A browser is a program that runs on your computer that allows you to browse the web pages on the internet. So examples of browsers are Chrome, Firefox, Safari, Internet Explorer, and Opera. And chances are you're using one of these to view this video right now. A browser is not an operating system like Windows or Mac. It's not a website like Google or Yahoo. It is an application, which is just a type of program that runs on your computer, that allows you to visit the websites on the internet. So how do we use a browser? Well, when you type a URL into the browser address bar, the browser goes out and retrieves all the HTML code, CSS code, images, videos, all the resources that make up the web page that lives at that URL, and downloads them off of the internet onto your computer. Once it has all those resources, the HTML code, the CSS code, any images, it takes all of those resources and packages them up and displays them as a usable web page. The result is a page that you can actually interact with. And all of that happened in less than a second. It's incredible. Now what's cool is that no matter what browser you use, generally you're going to be able to view the internet in the same way. There are some differences across browsers, but for the most part, every browser will allow you to browse the internet and view web pages in pretty much the same way, because all browsers buy into the same protocols for how HTML and CSS code should be displayed. It's very well defined how the code should be displayed, and if a browser wants to be used by people like us, then they need to buy into these protocols and display HTML and CSS code the way that they should be displayed. Now, it's very important to keep your browser up to date. Why is that? Well, every web page that you view is code that is running inside your browser. And some of that code might actually not be safe. Some web pages may try to attack your computer by doing things like installing viruses, tricking you into giving up information, things like that. Keeping your browser up to date helps prevent this. Having an up-to-date browser means that you have the latest bug fixes, that you have the latest security features, that you're able to use the most up-to-date versions of HTML and CSS because those languages are also always changing, and an up-to-date browser likely runs faster. So it's very important to keep your browser up to date. Now, there are a lot of browsers to choose from. All of them are free.
All right, we're not going to go into all the different browsers. You're probably using Chrome or Edge now, which actually runs a lot of the same stuff that Chrome does, or Firefox, probably the 3 most popular browsers. And these browsers, they have it's a program, so they have everything it needs to do. When you go click on a web page, it goes out and tries to find it, knows what to do when you do that. But again, remember he was saying is it just sends you some files, and then the browser's like, okay, I have these files. This is what the web page should look like based on those files. Now, I'm not going to do it in this class. I've done it in another class. But you can take a text file, call it, well, as long as you just put the code in there, like the code that we're going to create, you can create a text file, not a Microsoft Word document or something like that, but a text file with like TextEdit or Notepad or Notepad++. And you type in HTML, you can actually, you should call it something like index.html. If you tell it to open with the browser, if you name it index.html, the browser will just know. Normally the computer will be able to open that. It'll know to open that. If you put the right code in there, you could call it .txt. The browser still, all it does is it looks at that file and it interprets it and then turns it into what you see. That's all there is to the browser. That's what it does. So you could literally take a file that has HTML code in it, and a browser could open it and display it as if it was actually on the internet. Because that's all it really does. When you go out to the servers like we saw in the last one, it sends you a file. Your browser looks at that file and says, okay, this is what the web page should look like. So we got one more video. This kind of re-go over the request one more time. And we have a lesson on how some of this works, like example.com/homepage. And if you have like /pics, blah, 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 We have a whole video on kind of how the file system works. That's in a later week, but this is a little bit more on the request.
Hi. In this video, we'll be going through the step-by-step process of viewing a web page on the internet. What is the story there? What does that look like? Today we'll be going through the step-by-step process of rendering a web page. So at this point, we know how to make web pages. We've been writing the HTML code, we've been writing the CSS code, and seeing the result. The question is, how do we let the world see these web pages that we've been writing? How exactly, when you're browsing the web, how exactly does your browser find and display a web page onto your computer? Well, it all starts with the URL. That is the first step. And this can be typing it into the browser, it can be clicking on a link, it can be refreshing a page. All of these reference a specific URL, and the URL is where the story begins. So this is an example URL. URL stands for Uniform Resource Locator. The idea here is you are locating a resource that exists somewhere on the internet. And the URL specifies exactly what resource you want and where it is located. So there's two parts to the URL. The first part is the domain. This is where in the internet you need to look for the resource. So the URL specifies that this resource is located at www.example.com. This is where in the internet we need to go to look. The next part is the path, and the path specifies exactly which resource we're requesting. So once we get to example.com, we need to ask example.com for a specific file or a specific resource. And this can be anything. It can be an HTML file, it can be an image file, it can be a music file, but these are all examples of resources that we can request from the domain, from example.com. So the domain and the path. Now, once we type that URL into the browser, the next thing that happens is from that URL, your browser generates a request. And that request is sent off into the internet, and it pretty much says, hey, example.com, are you out there? Can you send me your homepage.html file, please? And now, the internet's a big place. It's connecting every single device on the planet that has an internet connection. So we are connecting laptops, we're connecting cell phones, we're connecting little watches. But there's also another type of machine that's connected to the internet. And these machines are what are serving up all of our web pages, serving up all of these resources. And those machines are called servers. So within this network, there are several servers, and each server sits at a certain location on the internet. So each of these domains, google.com, codehs.com, example.com, those are specific addresses, specific little circles within this massive network of the internet. And each of these servers just sits at that location and listens for requests. So when you send out your request to example.com, there is a server sitting at example.com waiting to hear your request. So your browser sends out the request saying, hey, example.com, can you send me your homepage.html file, please? Now, in reality, it's not so simple. The actual request looks like this behind the scenes. It's got a lot of information, a lot of special things that you're requesting, like which language you want, what type of file you want, and the exact layout for this request is defined by a protocol called HTTP. But right now, we don't really have to worry about that. The exact format of the request doesn't matter so much as what the request is actually getting at. And it's pretty much saying, hey, example.com, can you send me your homepage.html file, please? Now, the systems in the internet will forward your request all the way to that server that is waiting at example.com, and the server hears the request and provides a response. So this is the third step, is the response. And the server pretty much says, oh, homepage.html, yeah, I got that right here. Here you go. And it sends that file back over the internet to your browser. And now your browser has homepage.html in the response. And this brings us to the fourth step. Now that your browser has the file, it has homepage.html, all it has to do is render that HTML file into the resulting web page. So what it does is it goes through the browser, and the result is that beautiful web page, just like we've been seeing. You can write the code, and the resulting web page is this beautiful interactive thing. And so now that your browser has rendered the page, you can view it right on your computer. And that all happened in less than a second. It's pretty incredible. So those are the 4 steps to viewing a web page: the URL, the request, the response, and then rendering the page. So what if we want to host our own website? What are the steps there? Well, if we want our web pages, if we want our HTML files to be available to the world, the first thing we have to do is register a domain.
All right, so we're actually going to do this at the end of this week's lessons. Kind of. I mean, if you want to go register your own domain, that normally costs money. There are some ways to get free. You can Google it, and like I think there's some TK domains or something that you can get for free. But then you have to do a bunch of routing and stuff. So what we'll do is we'll go to a web hosting server, right? We'll go to someone who has all the servers for us. We'll get an account with them, and then basically we'll use their domain, 00webhost, and then with that you'll get like a subdomain under them. But again, something that you'll have this web page file. You'll create this file, and it will send it to them. So that's how hosting works. Whether you're going to go get someone else's web page, or if you create a web page, if you've taken any web classes before on Code High School, code.org, any of those, any web page you're making is actually a web page inside of a web page on their server. What we're going to learn now is you're going to have your own server, more or less. You're creating the file system and everything like that. So that's how this all works. And this video did a pretty good job summarizing everything that we went over in the last two videos, kind of put it all back together for us. So what we're going to do real quick before we finish up is show you what I'm talking about. So if I go over here, and I gotta get off of this, let's just open up a new tab. If I right click on this and I click inspect, all of this right here, all of this code down here that you see, all of it is what this is. So this picture, this little bar, these little icons, all this up here, all of that is because of this. So we'll go over what the head means. Look at all of this code that's just in the head. Whatever's in the body. You can see this highlights blue, this top part up here, because the body is what actually shows up on the screen. So this is saying, hey, this is all this. When I go down here, this piece of code right here is that blue line right there. So all of this code is what we're going to learn. And this is what the browser does. This is a file. This right here was all of the text that was sent from Google, and now it creates this file. So with that, have a good day. We'll talk to you next lesson.